pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. And today I am going to discuss about CNN, that is convolutional neural network. A convolutional neural network have revolutionized the field of computer vision, enabling the remarkable advancement in tasks such as image classification, object detection, and image segmentation. With their unique architecture, the ability to extract the hierarchical features from image, a CNN has become a backbone of many state-of-art of deep learning model. Let us explore the background architecture, advantages and disadvantages of CNN and their significance in the realm of computer vision. The main background draws the inspirations from the organization of the visual context in the human brain, where neurons in different layers respond to the visual stimuli with the increasing complexity. The pioneering work of Jan Newlin and others in the late of 1990s laid the foundations for CNN by introducing a convolutional layer, pooling layer, and the concept of weight sharing, while significantly improving the significant efficiency and effectiveness of the image processing task. The main architecture of this convolutional layer, the core building block of CNN or a convolutional layer, which applies a set of learnable filters, a kernel to the input image to extract the features such as edge, texture, and the shape. The convolutional operation perceives a spatial relationship between the pixel and enabling the network to capture the local pattern. A pooling layer down capable the feature map generated by a convolutional layer, reducing the spatial dimension while preserving an important information. Common pooling operation includes a maximum pooling and the average pooling, which helps in achieving a translation invariance and reducing a computational complexity. An activation function, a non-linear activation function such as a rectified linear unit or applied after the convolution and the pooling operation to introduce a non-linearity into the network and enabling it to learn a complex mapping between the input and the output. Fully connected layer, the final layers of the CNN typically consisting of one or more few fully connected layer which performs the classifications or the regression task based on the extracted feature. This layer connects every neurons in one layer to each neurons in the next layer, allowing the network to learn a complex decision boundaries. The advantages of CNN were hierarchical feature learning. The CNN automatically learns the hierarchical representations of the feature from a raw pixel value, enabling them to capture a complex pattern and the structure in imaging. Translation invariance by using a shared weights and the pooling operation. CNN are inherently invariant to translation to the input, making them robust to variations in object positioning and orientation. The parameter sharing, the use of the shared weighted in the convolutional layer reduces the number of parameters in the network, making the CNN more computational efficient and reducing the risk of overfitting. The transfer learning by pre-trained CNN models on a large subset data sets like ImageNet can be fine-tuned on smaller domain-specific data sets with limited labeled examples, allowing for effective transfer learning and a rapid development of customized model for a specific task. The disadvantages of CNN were a limited context information. CNN has a fixed representative and field size determined by a kernel size and the number of convolutional layer, limiting their ability to capture a long range of dependency and a global context in imaging. The computational complexity, a deep CNN architecture with the multiple layers and the parameters can be computationally expensive to train the required sustainable computational resources, especially for large scales of data sets. The data requirement, the CNN requires a large amount of labeled trained data to learn a meaningful representation and generalized well to unseen example, which which may not be always be available for a certain task or a domain. The conclusion, in as I conclude, the convolution neural network emerged as a powerful tool for tackling a wide range of computer vision tasks. The hierarchical architecture and the efficient parameter sharing, the ability to automatically learn hierarchical feature from a raw pixel value, provide them to forefront of image processing and analysis. I hope you are clear with this concept. Thank you.